the interstellar visitor. Since 2017, we've encountered a new class of celestial objects, interstellar objects. They're visitors from beyond our star system, and the third one ever confirmed, 3I/Atlas, is arguably the most bizarre. Discovered in 2025 by the Atlas Survey, this object, originally classified as a comet, is rewriting the rules of what a deep space wanderer should be. Its behavior is so unexpected, it's fueled a question once reserved for science fiction. Is this object entirely natural? The anomalous behavior 3I/Atlas immediately stood out with its extreme speed and hyperbolic trajectory, confirming its origin from a distant star system. But that was just the beginning of the strange observations. Unexplained acceleration. All comets, including interstellar ones, can be slightly accelerated by the gases jetting off their surfaces. This is called non-gravitational acceleration. However, the amount and direction of the non-gravitational acceleration detected in 3I/Atlas couldn't be easily reconciled with standard cometary outgassing. It's as if something gave the object an extra measurable kick that gravity alone can't explain. Peculiar light and color shifts. As 3I/Atlas approached the Sun, it exhibited an unprecedented rapid increase in brightness, far exceeding what astronomers expected. Furthermore, its light signature displayed surprising color shifts, most notably an unusual shift to blue near perihelion, which is rarely, if ever, seen in natural comets. The anti-tail comets typically have tails pointing away from the Sun, pushed by solar radiation and solar wind. 3I/. Atlas showed signs of a faint, normal tail, but observations also hinted at an anti-tail, a stream of dust seemingly pointing toward the Sun. While this feature can sometimes be an optical illusion due to viewing geometry, its appearance added to the mounting list of peculiarities. Unusual composition. Initial spectral analysis of its coma also suggested an unusual chemical cocktail, including the detection of atomic nickel without the accompanying iron often found in natural space rocks. Nickel is a common material in our solar system, but its distinct signature in 3I/Atlas contributed to the object's unique profile. The debate: natural versus artificial. These anomalies have divided the scientific community. The prevailing view among most astronomers is that 3I/Atlas is indeed a natural comet, albeit a very unusual one. The natural explanation experts argue that its strange behavior can likely be explained by natural, though rare, phenomena. The rapid brightening may be due to the object entering an explosive new phase of mass loss, or being fragmented during its close passage to the Sun. The non-gravitational acceleration is likely a product of jets of volatile, unseen ices, like frozen nitrogen or carbon monoxide, being ejected at a high velocity. Since the object came from a different star system, its composition and internal structure would naturally be different from our local comets. As NASA's Small Bodies lead scientist Tom Statler put it looks like a comet. It does comet things. The evidence is overwhelmingly pointing to this object being a natural body. The non-natural hypothesis. However, the most visible expert opinion regarding a non-natural origin comes from Harvard astrophysicist Dr. Avi Loeb. Citing the unique combination of the extreme, unexplained acceleration, the bright blue color, and the unusual composition, Loeb suggested a distinct possibility that 3I/Atlas could be a technological artifact, a piece of extraterrestrial engineering, or a probe. He argues that the acceleration could be a sign of a rocket-like propulsion system, and the uncharacteristic coloring could be a result of an artificial light source or a highly reflective engineered surface. He has publicly stated a significant likelihood that 3I/Atlas does not have a fully natural origin. Regardless of whether it's an unusually robust comet or something more exotic, 3I/Atlas is a crucial messenger. It offers an unprecedented opportunity to study material formed around another star, carrying with it secrets from a distant stellar nursery. Its ongoing unusual behavior demands continued monitoring. Astronomers worldwide are using every tool available to analyze its shape, composition, and trajectory as it speeds away. The hope is that future, more detailed observations will definitively link its strange behavior to a natural, if unexpected, scientific explanation, or perhaps for the first time, provide compelling evidence for an object of artificial origin. Free I/Atlas has passed the sun and is now racing back into the dark. Its brief visit has left us with more questions than answers, reminding us that in the cosmos, the most logical explanation is often just the one we haven't discovered yet.